In 1985, the National Electrical Code, specifically Article 680.22, mandated ground fault circuit interrupter, or GFCI, protection for whirlpool bathtubs. This requirement was integrated into the 1984 edition of the NEC. When purchasing a home, a final electrical inspection is typically required by local codes to guarantee that the electrical installation adheres to safety standards. The electrical inspector's insistence on a GFCI breaker is accurate. The immediate tripping of the breaker suggests an issue within the tub's electrical system. Possible causes include, firstly, a ground fault within the tub's wiring or components, secondly, a defective control panel, and thirdly, a faulty motor or pump. If accessing the under-tub control panel is impossible, removing the surrounding ceramic tile may be necessary. This is a complex task requiring specialized equipment and expertise. To address the issue, you have a few options. Firstly, hire a qualified electrician. A licensed electrician is equipped to safely diagnose and repair the electrical system, ensuring the correct installation of a GFCI breaker. Secondly, you may need to remove the ceramic tile. If needed, removing the tile grants access to the control panel for repairs or adjustments. However, this choice is more intrusive and costly. It's crucial to recognize that the local electrical inspector possesses the authority to enforce local electrical codes. If the code mandates a GFCI breaker for your tub, compliance is probably necessary to sell the home. Ground fault circuit interrupters, GFCIs, are crucial safety devices designed to protect individuals from electrical shock. They function by continuously monitoring the balance of electrical current flowing through a circuit. In a properly functioning circuit, the current flowing to an appliance or device should equal the current returning. If a difference exists, even as small as a few milliamps, it indicates that current is leaking out of the circuit, potentially through a person. When a GFCI detects such a current leakage, it quickly trips the circuit, cutting off the power supply and preventing a potentially fatal electric shock. Several factors can cause a GFCI to trip. A ground fault occurs when current leaks from a hot wire to a grounded surface or a ground wire. This can happen due to damaged insulation, loose wiring, or moisture within an electrical device. Short circuits, where a hot wire comes into direct contact with a neutral wire, can also cause a GFCI to trip, though these often trip standard circuit breakers as well due to the high current flow. Faulty appliances are a common culprit. Internal wiring problems, damaged components, or moisture intrusion within an appliance can create a ground fault that triggers the GFCI. Furthermore, GFCIs themselves can malfunction over time, becoming overly sensitive or failing to reset. Nuisance tripping refers to instances where a GFCI trips without an apparent fault. This can be caused by minor fluctuations in the electrical system, such as voltage spikes or electromagnetic interference. In older homes, shared neutral wires between circuits can also lead to nuisance tripping. Identifying the root cause of a GFCI trip can be challenging. Start by checking all appliances plugged into the circuit for any signs of damage or moisture. Unplug them one by one and reset the GFCI after each one to see if the tripping stops. If the GFCI trips immediately upon resetting, there may be a problem with the wiring or the GFCI itself. In this case, it is best to consult a qualified electrician. When dealing with electrical systems, safety should always be a top priority. Before working on any electrical circuit, turn off the power at the main breaker panel. Use a non-contact voltage tester to verify that the power is off before touching any wires or components. If you are not comfortable working with electricity, or if you are unsure about any aspect of the repair, it is always best to call a licensed electrician. They have the knowledge, experience, and equipment to safely diagnose and repair electrical problems. Several methods exist for testing a ground fault circuit interrupter, or GFCI, to ensure it functions correctly. Firstly, the most common method involves using the test and reset buttons located on the GFCI outlet itself. Pressing the test button simulates a ground fault, causing the GFCI to trip and cut off power to the circuit. To restore power, the reset button must be pressed. If the GFCI fails to trip when the test button is pressed, or if it cannot be reset, it indicates a malfunction, necessitating replacement. Secondly, a GFCI tester, available at most hardware stores, offers a more comprehensive evaluation. This device plugs into the GFCI outlet and, when activated, simulates a ground fault. The tester typically includes indicator lights that confirm whether the GFCI trips correctly and whether the wiring is properly connected. Thirdly, a multimeter can be employed to directly measure the ground fault trip time. This involves connecting the multimeter to the outlet and using a specialized adapter to simulate a ground fault. The multimeter measures the time it takes for the GFCI to trip, which should be within the manufacturer's specified range, typically a few milliseconds. Fourthly, it's important to visually inspect the GFCI outlet for any signs of damage, such as cracks, discoloration, or loose wiring. Any visible damage may compromise the GFCI's functionality and warrant replacement. Fifthly, regularly testing GFCIs is crucial, ideally monthly or at least twice a year. Consistent testing ensures that the GFCI remains responsive and capable of protecting against electrical shock. Failing to test GFCIs regularly can lead to a false sense of security, as the device may fail to operate when needed. Sixthly, when replacing a GFCI outlet, it's essential to choose a model that meets current safety standards and is compatible with the existing electrical system. Additionally, follow the manufacturer's instructions carefully during installation and ensure that all wiring connections are secure. By diligently testing and maintaining GFCIs, homeowners can significantly reduce the risk of electrical hazards and ensure the safety of their families. Troubleshooting a tripping ground fault circuit interrupter, or GFCI, requires a systematic approach to identify the underlying cause. Firstly, begin by unplugging all appliances and devices connected to the GFCI protected circuit. This isolates potential sources of ground faults. Secondly, reset the GFCI. If it holds without tripping, gradually plug in each appliance one by one, observing if any specific device causes the GFCI to trip. This helps pinpoint faulty appliances. Thirdly, inspect the wiring and outlets for any signs of damage or loose connections. Look for frayed wires, cracked outlets, or evidence of moisture. Fourthly, check for shared neutral wires, particularly in older homes. Shared neutrals can cause imbalances that trigger nuisance tripping. Fifthly, test the GFCI itself using the test button. If the GFCI fails to trip or reset properly, it may be defective and require replacement. Sixthly, consider environmental factors. Moisture, humidity, or excessive electrical noise can sometimes cause GFCI tripping. Seventhly, if the problem persists, consult a qualified electrician. They can use specialized equipment to diagnose complex wiring issues or hidden ground faults. Eighthly, ensure that the GFCI is properly rated for the circuit's amperage. An undersized GFCI may trip prematurely. Ninthly, document all troubleshooting steps taken and observations made. This information can be helpful for the electrician if professional assistance is needed. Tenthly, prioritize safety. Always turn off the power to the circuit before working on any electrical components. Ground faults present a serious shock hazard. Moreover, a methodical approach to troubleshooting, combined with careful inspection and testing, can often identify the cause of GFCI tripping and restore safe operation. The National Electrical Code, or NEC, Article 680.22 specifically addresses the requirements for ground fault circuit interrupter, or GFCI, protection for hydromassage bathtubs. Firstly, the NEC mandates GFCI protection for all 125-volt single-phase receptacles within 6 feet of the inside edge of a hydromassage bathtub. Secondly, this requirement applies to both new installations and replacement receptacles. Thirdly, the purpose of GFCI protection is to minimize the risk of electrical shock to individuals using the bathtub. Fourthly, the GFCI device must be readily accessible and located in a place where it is unlikely to be accidentally damaged. Fifthly, the NEC also requires that the hydromassage bathtub motor and pump be GFCI protected. Sixthly, this protection can be provided by a GFCI circuit breaker or a GFCI receptacle. Seventhly, the GFCI device must be listed and labeled for use with hydromassage bathtubs. Eighthly, the NEC allows for exceptions in certain situations, such as when the bathtub is permanently wired and does not have any receptacles within 6 feet. Ninthly, it is important to consult the latest edition of the NEC and local electrical codes for specific requirements and interpretations. Tenthly, compliance with NEC Article 680.22 ensures a safe electrical installation for hydromassage bathtubs. Accessing the control panel of a Jacuzzi whirlpool bathtub can vary depending on the model and installation. Firstly, some Jacuzzi tubs have an access panel located on the side or end of the tub. This panel is usually held in place by screws or clips and can be easily removed to reveal the control panel. Secondly, other Jacuzzi tubs may require removing a section of the surrounding wall or flooring to gain access to the control panel. This is more common in tubs that are enclosed or built into a platform. Thirdly, if the tub is installed against a wall, it may be necessary to cut an access hole in the wall behind the tub. This should be done carefully to avoid damaging any plumbing or electrical wiring. Fourthly, some Jacuzzi tubs have a removable front apron that provides access to the control panel. This apron is typically held in place by screws or clips and can be easily removed. Fifthly, if the tub is surrounded by ceramic tile, it may be necessary to carefully remove some of the tiles to gain access to the control panel. This should be done with caution to avoid damaging the tiles or the tub. Sixthly, before attempting to access the control panel, it is important to turn off the power to the tub at the circuit breaker. This will prevent electrical shock. Seventhly, once the control panel is accessed, it is important to identify the components and wiring before making any adjustments or repairs. Eighthly, if you are not comfortable working with electrical wiring, it is best to consult a qualified electrician. Ninthly, when reinstalling any access panels or tiles, make sure they are securely fastened to prevent leaks or damage. Tenthly, always refer to the Jacuzzi owner's manual for specific instructions on accessing the control panel for your model of tub. A ground fault in a whirlpool bathtub can be a dangerous situation as it can lead to electrical shock. Firstly, a ground fault occurs when electrical current leaks from a hot wire to a grounded surface, such as the metal frame of the bathtub or the water inside the tub. Secondly, this can happen due to damaged insulation on the wiring, loose connections, or moisture intrusion. Thirdly, the most common symptom of a ground fault is a tripping ground fault circuit interrupter, or GFCI, which is designed to protect against electrical shock. Fourthly, if the GFCI trips repeatedly, it is a sign that there may be a ground fault in the bathtub's electrical system. Fifthly, to troubleshoot a ground fault, start by unplugging the bathtub and inspecting the wiring for any signs of damage or loose connections. Sixthly, check the pump and motor for any signs of moisture or corrosion. Seventhly, use a multimeter to test the continuity between the hot wire and the ground wire. If there is continuity, it indicates a ground fault. Eighthly, if you are not comfortable working with electrical wiring, it is best to consult a qualified electrician. Ninthly, a ground fault can be difficult to locate, as it may be hidden inside the bathtub's components. Tenthly, it is important to address a ground fault immediately to prevent electrical shock. Removing ceramic tile to access a Jacuzzi control panel requires careful planning and execution to minimize damage. Firstly, gather the necessary tools including a grout removal tool, a hammer, a chisel, a putty knife, safety glasses, and gloves. Secondly, begin by removing the grout around the tiles you intend to remove. A grout removal tool or a utility knife can be used for this purpose. Thirdly, gently tap the chisel behind the tile, working your way around the edges to loosen it. Avoid applying excessive force, as this can crack the tile. Fourthly, once the tile is loosened, use the putty knife to carefully pry it away from the wall. Fifthly, if the tile is particularly stubborn, you can try using a heat gun to soften the adhesive. Sixthly, clean the back of the removed tiles and the exposed wall surface to remove any remaining adhesive. Seventhly, label the tiles to ensure they can be reinstalled in the correct order. Eighthly, store the removed tiles in a safe place to prevent damage. Ninthly, once you have access to the control panel, perform the necessary repairs or adjustments. Tenthly, when reinstalling the tiles, use a high-quality tile adhesive and grout. Ensure the tiles are properly aligned and spaced before the adhesive sets. The authority of an electrical inspector is derived from local and national electrical codes and regulations. Firstly, electrical inspectors are responsible for enforcing the National Electrical Code, or NEC, which is a set of standards for safe electrical installations. Secondly, local jurisdictions may also have their own electrical codes that are more stringent than the NEC. Thirdly, electrical inspectors are typically employed by local governments such as cities or counties. Fourthly, they are authorized to inspect electrical installations in residential, commercial, and industrial buildings. Fifthly, electrical inspectors have the power to issue permits for electrical work and to require corrections to any code violations. Sixthly, they can also shut down electrical systems that pose an immediate danger to public safety. Seventhly, electrical inspectors are required to be licensed and certified, which ensures that they have the knowledge and experience to perform their duties. Eighthly, they must stay up to date on the latest changes to the electrical codes and regulations. Ninthly, electrical inspectors play a crucial role in ensuring the safety of electrical systems and preventing electrical fires and injuries. Tenthly, their authority is essential for maintaining public trust in the safety of the electrical infrastructure. Hiring a qualified electrician is crucial for ensuring the safety and proper functioning of electrical systems. Firstly, a qualified electrician has the necessary training, experience, and licensing to perform electrical work safely and effectively. Secondly, they are knowledgeable about the National Electrical Code, or NEC, and local electrical codes, ensuring that all work is done in compliance with regulations. Thirdly, a qualified electrician can accurately diagnose electrical problems and provide appropriate solutions. Fourthly, they have the tools and equipment necessary to perform electrical work safely and efficiently. Fifthly, hiring a qualified electrician can prevent electrical fires, shocks, and other hazards. Sixthly, they can also help to improve the energy efficiency of your home or business. Seventhly, a qualified electrician can provide documentation and permits for electrical work, which is often required by insurance companies and local authorities. Eighthly, they can also offer warranties on their work, providing peace of mind. Ninthly, when choosing an electrician, it is important to check their credentials, read reviews, and ask for references. Tenthly, hiring a qualified electrician is an investment in the safety and value of your property. Electrical safety is paramount when dealing with any electrical system, regardless of its complexity. Firstly, always turn off the power at the main breaker panel before working on any electrical circuit. Secondly, use a non-contact voltage tester to verify that the power is off before touching any wires or components. Thirdly, never work on electrical systems when you are wet or standing in water. Fourthly, wear rubber-soled shoes and use insulated tools. Fifthly, inspect electrical cords and plugs for any signs of damage. Sixthly, never overload electrical circuits. Seventhly, use ground fault circuit interrupters, or GFCIs, in areas where water is present. Eighthly, install smoke detectors and carbon monoxide detectors in your home. Ninthly, have your electrical system inspected regularly by a qualified electrician. Tenthly, if you are not comfortable working with electricity, always call a licensed electrician. These measures are essential for preventing electrical shocks, fires, and other hazards. Replacing a ground fault circuit interrupter, or GFCI, outlet is a straightforward process, but it's crucial to follow safety precautions. Firstly, turn off the power to the circuit at the main breaker panel. Secondly, use a non-contact voltage tester to confirm that the power is off at the outlet. Thirdly, remove the faceplate and unscrew the old GFCI outlet from the electrical box. Fourthly, carefully disconnect the wires from the old outlet, noting their positions. Typically, there will be a hot wire, a neutral wire, and a ground wire. Fifthly, connect the wires to the new GFCI outlet, matching the positions to the terminals. The hot wire usually connects to the brass terminal, the neutral wire to the silver terminal, and the ground wire to the green terminal. Sixthly, gently fold the wires into the electrical box and screw the new GFCI outlet into place. Seventhly, attach the faceplate. Eighthly, turn the power back on at the main breaker panel. Ninthly, Test the GFCI outlet by pressing the test button. The outlet should trip, cutting off power. 10thly, press the reset button to restore power. If the GFCI outlet does not function properly, recheck the wiring connections. The local electrical codes often supplement the National Electrical Code, or NEC, to address specific regional needs and concerns. Firstly, local codes may be more stringent than the NEC in certain areas, such as requiring additional safety measures for buildings in earthquake-prone zones. Secondly, local codes may also address unique environmental factors, such as requiring specific types of wiring for buildings near the coast to resist corrosion from salt air. Thirdly, local codes are typically enforced by local electrical inspectors who have the authority to interpret and apply the codes. Fourthly, local codes can vary significantly from one jurisdiction to another, so it is important to consult the local codes before starting any electrical work. Fifthly, local codes are often updated more frequently than the NEC to reflect changes in technology and best practices. Sixthly, local codes may also address specific issues related to historic buildings or other unique structures. Seventhly, local codes are an essential part of ensuring the safety and reliability of electrical systems in a particular area. Eighthly, local code requirements must be followed in addition to the NEC. Ninthly, local amendments may exist due to weather and local conditions. Tenthly, it is important to contact local electrical authorities.